What is vapor pressure? Vapor pressure is the value of pressure exerted by the surface of the liquid when it is about to change its state to gaseous. The temperature is increased to make the vapor pressure value reach the value of pressure of ambient. As temperature increases, the pressure of the liquid also increases. This law is called as Gay-Lussac's law in thermodynamics. Define boiling point using atmospheric pressure and vapor pressure. We all have seen boiling water at least once in our lifetime. It is the point at which the liquid phase of a substance changes into gaseous phase. Whenever this happens, the ambient pressure and vapor pressure of the liquid will have same values. To achieve this equality, temperature of the liquid is increased continuously. As the temperature increases, pressure also increases. Boiling is observed by droplets of liquid rising up. Does boiling point depend on atmospheric pressure? Definitely yes. As we have discussed that vapor pressure, when reaches the value of atmospheric pressure, boiling takes place. If the value of atmospheric pressure is itself less, then it will take lesser amount of time for vapor pressure to touch the value of atmospheric pressure. This way the boiling point will be lower as compared to places where ambient pressure is more. Effect of atmospheric pressure on boiling point. We have clearly discussed in above section regarding the effects of atmospheric pressure on the boiling point of a substance. In a nutshell, we can say that atmospheric pressure and boiling both are directly dependent on each other. If one changes, then other one also changes. They both are directly proportional to each other, that is, if one quantity increases, other one will also increase. If the liquid starts boiling faster, then surely the atmospheric pressure outside would also be low. How to increase atmospheric pressure? Atmospheric pressure mainly depends on the gravity. Due to gravity, the molecules are attracted to the surface. So the atmospheric pressure will be more where the effect of gravity is more. In simple words, the places which are closer to the Earth's surface, sea level, those places will have more atmospheric pressure than the places having more altitude. Why does boiling point vary with atmospheric pressure? Until now we have discussed a lot about effect of atmospheric pressure on boiling point in early sections of this article. They both are directly related to each other, and boiling point is dependent on the value of atmospheric pressure outside the system. This is because when the vapor pressure at the surface of the liquid starts getting higher and getting closer to the value of atmospheric pressure, then the boiling starts taking place. If the value of atmospheric pressure is low, then the liquid will start boiling very easily and faster. How do atmospheric pressure and elevation affect boiling point? Gravity. Gravity is the main reason behind the entire episode of boiling point's dependency on elevation and atmospheric pressure. Gravity is more at Earth's surface and gets slightly lower as we go higher. Due to gravity, the molecules in the atmosphere get closely packed near the surface and are slightly scattered at higher elevations. We know the direct effect of atmospheric pressure and higher altitudes on boiling point of a substance. Boiling point and atmospheric pressure equation. Clausius-Clapeyron equation gives us a direct mathematical relationship between atmospheric pressure and the boiling point. Using this equation, a person can find the values of boiling point for different vapor pressure if only value of boiling point with its corresponding temperature is given. The equation is given as follows. Where will the water boil faster, surface or at the hilltop? After discussing so many points regarding effect of atmospheric pressure and elevation on the boiling point, now we can answer this question easily. At the surface level, the atmospheric pressure is more, and at the hilltop the atmospheric pressure is less. So it is safe to say that the water will boil faster at the hilltop due to low atmospheric pressure. It will take less time for the vapor pressure of water to reach a value equal to the atmospheric pressure. What is cavitation? Cavitation is related to boiling. It takes place inside a liquid when the local vapor pressure becomes lesser than the vapor pressure very rapidly. Cavitation is the localized boiling of the liquid particles that can be observed by bubbles and voids forming in the liquid. Cavitation is undesirable because it damages the mechanical components used in the machine. What is Bernoullis equation? The Bernoullis equation is given for incompressible fluids flowing in a streamline flow. This equation tells us that for a fluid moving in a streamline flow, the fluid particles will have constant energy throughout. In simple words, Bernoullis equation tells us that static pressure plus dynamic pressure equals total pressure. What happens to atmospheric pressure as we move upwards? As we move upwards, the effect of gravity becomes lesser. Hence, the molecules in the air get scattered and are loosely packed. Due to this, the atmospheric pressure value decreases. When we say this, the boiling point of a substance is getting directly affected. Due to low atmospheric pressure, the boiling point of the substance will also go down. What is the boiling point of water at standard pressure conditions? At standard atmospheric conditions, the atmospheric pressure is considered as 1 atm or 1.01 times 10 to the power of 5 Pa. At this point, the water will boil at 100 degrees Celsius or 212 degrees Fahrenheit. The conversions of units can be done by using their respective conversion formulae. In Kelvin, the boiling point temperature is 373.15 Kelvin. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.